Hi scholar, welcome to Post Scholars channel. If you are seeing this video for the first time, you are a special person and I celebrate you with an online kiss. If you are already a subscriber, I love you more. So the title of this video is Types, Properties and Relationship of Angles. This topic is very paramount and important. I want to assure you, if you are able to follow through this video, you'll be able to solve problems involving angles. So let's start by defining angle. An angle is formed when two rays, remember I already explained what ray is. I said ray is a line facing one direction, right? A line that is facing one direction. But when it's now facing either of both direction, it becomes a line, right? But if it's facing just one direction, it is a what? It is a ray, right? Good. So an angle is formed when two rays or line segments meet at a common endpoint called the vertex. Angles are measured in degree, you should know that, or radian, and their classification depend on their magnitude, position, and relationship with other angles. What does this simply mean? It simply means when two rays meet at a point, this one ray, right? And this is another ray, right? Now, once they meet at a particular point, it forms what? An angle, and the angle is always measured in what? In degree, right? So this is an angle, this is also an angle, right? You can see it's two rays. This is an angle, this is also an angle, right? It's also an angle, right? So whenever two lines meet, it forms an angle. Now let's continue. We want to classify angle now based on magnitude. Magnitude simply means size, right? We already told you here that angles can be classified depending on their size, their position, and their relationship. So the first thing we want to consider here is we want to consider angle, we want to classify angle based on their magnitude or size. So the first classification is zero angle. What's a zero angle? A zero angle, one property of a zero angle is that it's an angle that measures exactly 0 degree. The two rays lies on top of each other. That means if I want to draw a typical zero angle, it's like this. The first line goes like this, and the second line is on top of the first line, right? You can see it. So no angle is formed because the two lines are not meeting at a point. So that's what we call zero angle. So this is zero angle because the two lines are not meeting at a point. Now we move to the next one. The next one says acute angle. Right? What's an acute angle? An acute angle is an angle that falls between 0 degree and 90 degree. If you are conversant with your protractor, you will know that 90 degree is in between 0 and 180 degree. So let's quickly look at the properties before we analyze. One property of acute angle is that an acute angle is smaller than a right angle, right? So this is a typical acute angle. If this is your 90 degree, here is 90 degree, right? Definitely the angle, an acute angle must not be greater than 90 degree. This is 90 degree and this is 0 degree. That means your acute angle falls in between 0 and 190. It could be this, it could be this, right? So if I want to draw an acute angle, this is an acute angle. You can see it's not greater than what? 90. This is an acute angle. This is also an acute angle, right? You can see it's not greater than what? 90 degree. This is also an acute angle, right? Good. You can see it's not greater than what? 90 degree. Moving on, the third classification, right angle. Right angle. So right angle is an angle that measures exactly 90 degree. It measures exactly what? 90 degree. It is represented by a small square at the vertex. Now, what is a vertex? You should know what a vertex is by now. A vertex is where two lines meet. If, for example, this is a line and this is another line, this point here is called the what? Vertex, right? It's called the vertex. So what is a right angle? A right angle simply measure exactly what? 90 degree. So it is represented by a small square. So this is a right angle, right? If here is a right angle, here is also what? A right angle. Is that taken? So this is a right angle, 90 degree. This is also a right angle, 90 degree. This is also a what? Right angle, 90 degree, right? Both lines must be very straight. It must not be bent. Now moving on, obtuse angle, right? Obtuse angle. Obtuse angle falls between 90 degree and what? 180 degree. We have defined acute. We said acute angle is less than 90, but obtuse angle is greater than 90 but less than 180. Let's look at the description. Larger than a right angle but smaller than a what? Straight angle. Example are 120 degree, 135 degree. I didn't give example here. For acute angle, the example of acute angle will be what? 60 degree because it's less than 90, 30 degree, right? 20 degree, right? 95 degree cannot be an acute angle. Why? Because it's greater than what? 90 degree. Now let's continue with obtuse. Obtuse angle is greater than 90 but less than 180. So this is how our obtuse angle looks like. Draw a straight line, right? Then this is your 90 degree, right? Then the angle is now greater than what? So from here to here is an obtuse angle because it's greater than what? 90 degree. All right. So I can say from here to here measures, let's say for example, measures, let's say 125 what degree. So this is a typical example of an obtuse angle. So let's draw another one. This is also an obtuse angle, right? This is an obtuse angle, right? Theta. This is also an obtuse angle, right? Theta, right? Provided it's greater than what? 90. So examples are 99 degree, right? 120 degree, right? 160 degree, right? 175 degree, right? And so on and so forth. Next, we move to straight angle. A straight angle measure exactly what? 180 degree, just like your right angle. Your right angle measure exactly right 90 degree, while your straight angle measures exactly what? 180 degree. The two rays form a straight line, right? So this example of a straight angle, straight line, right? Good. So let's say this is the first ray and this is the what? Second ray, right? So from here to here is what? 180 degree. A straight line have the value of what? 180 degree. So we are done with straight line. Next we move to reflex angle, right? Reflex angle. Reflex angle is greater than 180 but less than what? 360 degree, right? So a typical example of a reflex angle will be from here to here. Okay, it's not straight. Let me make it straight. All right, so from here to here, right, forms a what? A reflex angle. You could see that at this point we have 90 degree and at this point we have what? 180 degree. You can see now it's greater than 90 and it's also greater than 180, but it's not greater than what? 360. Falls in between 360 and 180. So examples of reflex angle are 210 degree, you can see it here, and 300 degree. We also have 335 degree, provided it's between 180 degree and 360 degree, then it is a reflex angle. This is another example of a reflex angle, like this and like this, right? So this is a reflex angle, right? This is another reflex angle from here to here forms a reflex angle, right? Automatically the other part will be a what? Will be an acute angle. So next, number 7, full angle. Full angle is also known as complete angle and it measures up to what? 360 degree. It's a full rotation where two rays coincide after a full turn equal to 1 revolution, right? So what this simply means is that an angle that forms 360 degrees, a full angle. If I have a straight line, for example, right, from here to here, right, from this origin back to this point, right, forms what? 360 what? Degree. So it's called a full angle, 360 degree. It's just like your vehicle or your tire, your wheel. Your wheel forms 360 degree, right? The total angle in a wheel is equal to 360 degree. Even your wristwatch or your rubber band and those circular objects, 360 degree. Then we also have classification of angles by position, right? Classifying angles by position. Now the first one here we have is adjacent angle, right? So two angles that share a common vertex and a common side but do not overlap. Let me draw a typical example of an adjacent angle. If you have one ray, right, another ray, then one ray in the middle. So angle A, right, and angle B is actually what? Adjacent. Good. Angle A and angle B is adjacent. Why? Because two angles that share common vertex. So this is a vertex, right? This angle A is sharing this vertex and angle B is also what? Sharing this vertex, right? But do not overlap. Do you see it? So angle A and angle B are adjacent to each other, or they are also adjacent what? Angles. So in essence, angle A and angle B here are what? Are adjacent what? Angles. Next, we move to linear pair, angle called linear pair. A special case of adjacent angles whose non-common side form a straight line, right? So a linear pair add up to 180 degree. So this is a typical example of a linear pair You just draw a straight line, then this is another ray. So this, if this is angle A, then this is what? Angle what? B, right? So angle A and angle B forms a linear pair, right? And it's sum up to what? 180 degree. Angle A plus angle B sum up to what? 180 what degree. So next, move to another subtopic called classification by relationship. And what's the first one? Complementary angle, right? What are complementary angle? Two angles whose measure add up to 90, right? So whenever two angles add up to 90, automatically angles are what? Complementary. For example, 30 degree and 60 degree, they are complementary angles. Another one, let's say 50 degree, right, and 40 degree, they are what? They are complementary. Why? Because their sum add up to what? 90 degree, right? Another example is 80 degree, right, and 10 degree. These angles are what? Complementary. Why? Because their sum equal what? 90 degree, right? Next, move to supplementary angle quickly. Supplementary angle, two angles whose measure add up to 180 degree forms a supplementary angle. An example of supplementary angle are 120 degree and 60 degree. Another example of supplementary angle would be 150 degree, right, and 30 degree. Why? Because once you add 150 and 30, it sums up to what? 180 degree. Another example of supplementary angle would be 140 degree, right, and 40 degrees. So these angles are supplementary because when you sum it together, you have 180 degree. The next, we have explementary angle. Explementary angle. What? Explementary angle. Two angles whose measure add up to 360 degrees. So when two angles add up to 360 degrees, it is called explementary angle. For example, 270 degree and 290 degree. Once you add these two angles together, you have 360. That's why it's called explementary. Another example of explementary angle would be 300 degree, right, and 60 degree, right? So these two angles are explementary because their sum equals what? 360 degree. Next subtopic is angle formed by a transversal and parallel lines. Now, when a straight line called a transversal intersects two parallel lines, it creates angles with special relationship. I will explain what transversal is. So if you have two lines, right? If you have two lines, two parallel lines, right? The first one goes like this, right? And the second one goes like this. Now, two lines are parallel if they can never meet, right? You can see this line will continue to go like this infinitely, and this line also continue to go like this infinitely. They can never meet. But this line, if I should do another line here, this line and this line, they are not parallel. Why? Because if I continue to extend this one and I continue to extend this one, you see that they will meet here, right? So these two lines are not what? Parallel. So let's move on. We have established that this line and this line are parallel. Now, a transversal is any line that now cuts across these two parallel lines, which is this, right? This is a transversal, right? Good. Now, corresponding angle, right? We can form a corresponding angle from two parallel lines and a transversal, right? Now, what's corresponding angle? These are angles that are in the same relative position at each intersection, right? From this parallel line, the corresponding angle here are these parts, right? Angle A and what? Angle B. So we can say that angle A equals angle what? B. They are always equal. Corresponding angles are always equal. So angle A equals angle B. What's the reason? They are both what? Corresponding, right? Corresponding angle. Another corresponding angle we have here is this part, this angle. Let's name it angle C, right? Angle C and angle D, right? So similarly, angle C is equals to what? Angle what? D. What's the reason? They are both what? Corresponding angles, right? So that's basically what corresponding angle is. We also have another one, which is here, angle E, right? And angle F. They are also what? Corresponding angles, right? Then the last one, which is here, angle, let's name this one G, right, and angle H is also what? Corresponding what? Angles. Now we'll move to the next one, which is alternate interior angles. Now these are angles that are on opposite sides of the transversal. By now you know what a transversal is and are between the parallel lines. Now this is a typical example of an alternate interior angle. First of all, you draw two parallel lines, right? Two parallel lines. Then you draw a transversal. Now the alternate interior angle are, remember this is the transversal, right? This angle here, right? Remember these two lines are parallel, right? They don't meet, they are parallel. So the angle here, angle A, and the angle here, which is angle B, are equal. So angle A equals angle B. And what's the reason? They are alternate what? Alternate interior angle. Then similarly, angle C, right? Angle C here and angle D. Angle C and angle D are also alternate what? Interior angle, right? The reason why you call it interior is because it's in between the parallel lines. The angles are in between the parallel. That's why it's called alternate what? Interior, right? So angle A equals angle B, right? And angle C equals angle what? D. What's the reason? Alternate interior. Next, we move to alternate exterior angle, right? So let's draw two parallel lines first of all. One parallel line goes like this, then another parallel line goes like this, right? Then you draw a transversal, right? Now the alternate exterior angle here will be this angle, right? Angle A, right? And angle B. Good. So this angle here, angle A equals angle B, right? And they are both what? Alternate x. It simply means if angle A is 50 degree, definitely angle B will also be what? 50 degree. We also have another alternate exterior angle, which is here, right? So if here is angle C, right? Here will be what? Angle what? D. So we can say angle C also equals angle what? D. And what's the reason? Alternate exterior, right? That means if angle C here is 70 degree, right? That means D also will be what? 70 degree. Then we have what we call consecutive interior angle. Consecutive interior angle. These are angles that are on the same side of the transversal and are between the parallel lines, right? Consecutive interior angle are supplementary. By now you should know what supplementary angle means. It simply means angle that sum up to what? 180. So let's establish how a consecutive interior angle looks like. So you draw two parallel lines first of all, line that does not meet, right? Then you draw a transversal, right? Now consecutive interior angle is saying angle A plus angle B equals what? 180. That's why it's called consecutive interior. So angle A plus angle B must equal what? 180. It simply means if angle A is 100 degree, definitely angle B will be what? 80 degrees, so that the sum will equal to what? 180 degree. We also have another consecutive interior angle right here. Here is angle C and angle D. Similarly, angle C plus angle D equals what? 180. Take note, they are not the same. It's different from alternate exterior and alternate interior. All those ones are equal, but consecutive interior angles sum up to what? 180 degree. We have come to the end of this video. By now, you should be able to identify the types of angle, properties of angle, and relationship of angle, because in the next video we'll start solving problems. And if you don't know this principle, you don't know the types of angle and their relationship, it will be difficult for you to solve problems. So I want you to go over this video and watch this video over and over again until you understand concept of angle, the properties, types, right? So God bless you. I wish to see you in my next video. Bye.